Good morning, ladies, gentlemen, judges, and professors. First of all, we would like to thank you to IEOM Society for the opportunity to present one of our paper. Please let me introduce myself. My name is Garo Rafael from Charuma Negara University. Today, me and my friend Natasha and Sharon would like to present one of our paper with the ID is 99. The title is Land Manufacturing Approach Using SMED Method and Value Stream Mapping on the Spring Bed Production Floor at PT Alpha Jaya Manunggal Mandiri. With our supervisor here, Ms. Lina Gozali and Dr. Atar. Next.
The order of the presentation that we want to discuss is starting from introduction, literature review, method, result and discussion, and last for conclusion.
Okay, next this is some video that will be the following we will discuss, such as the initial layout on PT Alpha Jaya Manunggal Mandiri that will be recreated using SLP method. And also we've done some waste analysis on the spring bed production line here. Also, this is the alternative layout that's created using the systematic layout method. There is two alternatives, such as alternative layout 1 and alternative layout 2. And as you can see here, this is the new process activity mapping that will be done to identify the new chosen layout. And we've done some SMED implementation before and after. And also there is some value stream mapping here that will be current value stream mapping and future value stream mapping on the spring bed production line.
Start from introduction, PT Alpha Jaya Manunggal Mandiri is company engaged in manufacturing established in 1998, located in Tangerang and engaged in the furniture industry. PT Alpha Jaya Manunggal Mandiri is a manufacturing company engaged in the furniture sector to produce a couch, bed frame, spring bed, pillow, and each other. The production process on each operation line has a different production time. Making one spring bed requires a long machine setup time and has many non-value added operations in the spring bed production line. This condition causes waste in the spring bed production process, which carried out in the form of waste of motion, waste of weighting, waste of transportation, and each other. Next slide. Based on the result of the research conducted at the spring bed production line, the following are three objectives in minimizing the setup time and waste in the spring bed production line. First, to removing non-value added operation on the spring bed production process to minimize land time and cycle time. And second is implementing SMED method to minimize the setup time in the spring bed production process. And last is for creating future value stream mapping on spring bed production line at PT Alpha Jaya Manunggal Mandiri. Next slide.
For literature review, I want to discuss about three literature from this paper. First is for waste. What is the meaning of waste? In land manufacturing, waste is defined as anything that doesn't add value to a product or any cost incurred in a process that does not benefit the customer. While for single minute exchange of days, SMED is one of the improvement methods from land manufacturing, which is used to prepare the time needed to set up a change from production one type of product to another product model. The SMED concept was introduced in the 1960s by Shiego Shingo as one of the founders of the Toyota production system. The goal to be achieved is trying to speed up the setup time for the car body molding process. Value stream mapping is a lean management tool that helps visualize the steps needed from product creation to delivering it to the end customer. As with other business process mapping methods, it helps with introspection, understanding your business better, and analysis or process improvement. The next slide is a flowchart regarding the method of minimizing waste and setup time on a spring bed production line.
This is the activity mapping before lean manufacturing approach with waste analysis method is carried out. Every activity in the spring production process is described and recorded in this process activity mapping. As you can see in the table, the total distance is 84.5 meters and total time is 9,410 seconds, while for the total of operation is 26 and total for inspection is 3, then the total of transportation is 11, total of delay is 0, and finally the total of storage is 1.
This is waste identification process carried out in the spring bed production process, which can be seen here. There are three types of activities, namely value added, necessary non-value added, and non-value-added activities. In the process of waste analysis, non-value-added activities will be minimized so as to reduce production process time. There are four types of waste that occur in the spring bread production process, namely waste of transportation, waste on inspection, waste on mention, and waste on waiting. This is the time study of the spring bread production, which considers the cycle time, normal time, allowance, and standard time. For cycle time, it was measured using a stopwatch lighting feature. It was measured using the Westinghouse method. Normal time is the time of each work element that has considered reaching factor, and the way to get the normal time is the cycle time multiplied by the reaching factor. For allowance, the factors that determine it are the energy expended, or altitude, work movement, hydraulic temperature condition, and atmospheric condition. Standard time is the time for each work element that has considered allowance. The way to get the standard time value is the normal time added to the normal time multiplied by the percentage of the range.
Okay, now we have done the test, normality test, uniformity test, and sufficiency test. As you can see here, this is the normality test that were done using the help of software Minitab. The normality tests were done using the Anderson-Darling method. If the p-value greater than 0.05, then the data is normal. And you can see here, the data is normally distributed. Next. And this is the uniformity test that were done using the help of the software Minitab. As you can see here, we use 3 sigma on the uniformity test. And after the test of the uniformity, it can be seen here, the data of every operation is the uniform. Next. And then this is the sufficiency test that were done using the confidence level of 95%, and we use significant level of 5%. And if the number of theoretical data were less than the number of observation data, the data will be called sufficient. And as you can see here, the data of number of theoretical is less than number of observation data on every operation, so the data called sufficient. This is the operation process chart on spring bread production line. As you can see here, there is operation, rework, and inspection, also storage. Next. And then this is the flow process chart on spring bread production line. As you can see on the flow process chart, there is transportation, inspection, operation, and also storage without delay on the spring bread production line.
Is initial layout of PT Alpha Jaya Mandiri Mandiri. Alternative layout is made use systematic layout planning method there, where the layout is made based on the level proximity between station. Based on the layout, it can be seen the result of obtained are is in the form of two alternative layouts, namely an alternative layout 1 and alternative layout 2. Next slide. This is the alternative layout 1 for PT Jaya Manuga Mandiri, can be seen in the picture. Next slide. And this is alternative layout 2 for PT Jaya Manuga Mandiri, can be seen in the picture.
And now we move to the new process activity mapping for the alternative layout 1 and also alternative layout 2. As you can see here, after the implementing the voice analysis, the non-value added activity will be removed. And as you can see, there is some decrease on the total operation from 41 becoming 36 activity. And for the time on the alternative layout 1 were decreased from 9,410 seconds becoming 8,704 seconds. And for the distance on the alternative layout 1 have been decreased to from 85 meters becoming 44.5 meters. Next. And this is for the new process activity mapping for the alternative layout 2. As you can see here on the alternative layout 2, the distance have been decreased from 85 meters becoming 36.75 meters. And also on the production activity time have been decreased from 9,410 seconds becoming 8,568 seconds. And same as the alternative layout 1, the process activity remove the non-value added activity and becoming 36 total activity. Next. And this is the comparison of the old layout, alternative layout 1 and alternative layout 2 based on the process activity mapping. As you can see here, the most minimum distance and operation time can be found in the alternative layout 2. So the alternative layout 2 will be chosen as the new layout that will be implemented on the Spring-Batch production line. Next.
Spring-Batch setup activity before the SMED implementation can be seen in the screen, which can be seen there before implementation of SMED method is setup activity were done when the machine is not operating, so it can be categorized as internal activity. This is setup activity for activity frame and activity edge where production station, and this is for the assemble and from sticky station. And this is the setup activity before SMED implementation on Spring fabric and production station, and type edge and packing station can be seen in the screen.
After the implementation of the SMED method, there is some activity converted into an external activity, such as taking the raw material from the raw material storage, etc. By converting some internal activities to external activities, the setup time for the Spring-Batch production process was reduced by 165 seconds, decreasing the setup time by 23.23%. Then, from the implementation of SMED, some setup activity has been eliminated because the setup activity can be done before the production process starts, such as taking the goods from the auxiliary material warehouse, etc. The setup time for eliminating some setup activity was reduced by 111 seconds, which decreased by 15.63% from the implementation of SMED. The total setup time was reduced from 710 seconds to 434 seconds, which reduced the setup time by 38.86%. This is the comparison can be seen in the screen, which before the SMED implementation, the initial activity for setup activity is 710 seconds, and after the SMED implementation, there is some decrease on the setup activity, becoming 434 seconds. It can be seen here, the SMED method converts some activity become external activity for 165 seconds. And there is some setup activity that were eliminated because the setup activity can be done before the machining process is begun.
And next we move to the value stream mapping. As you can see here, this is the current value stream mapping on the Spring-Batch production line, where the Spring-Batch production process can be seen on the below on the screen. And as you can see here, from the current value stream mapping, the lead time on the Spring-Batch production line is 720 seconds. The processing time on the Spring-Batch production line is 9,410 seconds, and for the setup time is 710 seconds. Next. And you can see here, this is the future value stream mapping. After we implement the waste analysis, removing the non-value added activity, implementing the new chosen layout, and also implementing the single minute exchange of dice method. As you can see here on the future value stream mapping, there is some decrease on the lead time, is becoming 435 seconds, and on the processing times become 8,568 seconds. And the last is for the setup time decreased to becoming 434 seconds. Next. And this is the standard time comparison for the current value stream mapping and future value stream mapping. As you can see here, the Spring-Batch frame production reduced by 9.58%. For the edge wire production become reduced by 45.3%. For the assembly and foam sticking reduced by 5.4%. For the fabric production reduced by 10.82%, and the last is for the type edge and packing station reduced by 0.2%. Next. And this is the proposed improvement. As you can see here, there is some decrease on the setup time by 38.86%, for the lead time decreased by 39.58%, for the distance decreased by 56.77%, and the production time decreased by 8.95%. Next. And this is the conclusion for our research. As you can see here, first is from the waste analysis, there is 5 non-value added activity on the Spring-Batch production line, then that will be eliminated to reduce the Spring-Batch production time. So we create the new alternative layout with using the systematic layout planning method, and there is 2 alternative layout, and then will we continue to choose the layout based on the process activity mapping. And based on the process activity mapping, the alternative layout 1 and alternative layout 2 can decrease the distance and operation time, but the most minimum can be found on the alternative layout 2. So the alternative layout 2 chosen as the new layout. And for the chosen new layout, it decreased the distance from 85 meters becoming 36.75 meters. Also on the spring-wet production activity decreased from 9,410 seconds becoming 8,568 seconds. And then the total activity becoming 36 activity. And then by implementation of single minute exchange of the method, there is some decrease on the setup time on spring-wet production line, which is from 710 seconds becoming 434 seconds. Next. And then this is the reference that we use on our research. And now next. And now we will move to question and answer session. I would like to give it back to the session chair. Thank you.
All right, thank you very much. ID number is 99. All right, so we open for question. Guests in the room, you can raise a question, or else I will raise a question. You have any question, guys? All right, so I think I have several questions I need to ask. Okay, just want to know if you look at your data collection, all right? In your data collection, you table out table 1 process activity mapping, all right? Okay, so just want to know the time second. Let's say, for example, in process a spring back frame production station, the time second for the raw material storage is 45 seconds. So I just want to know how many times you do a time taken to end up with 45 seconds. Are you referring to the real activities, or you are referring to the time that has been stated in the SOP or in other form?
Okay, thank you for the question, sir. I would like to answer. On the time we have by the real time when the workers doing their activity on the spring-wet production line. And we have taken the data by 30 times. So this is the mean of the 30 data that we have taken. So for taking the cycle time, after that we continue by considering the rating factor and also the allowance. So becoming the standard time on the process activity mapping.
All right. So from your answer, it comes to second question. Okay, this is lead to the next question. The next question is if you go to your table 3, the cycle time, rating factors, normal time allowance, and standard time. All right. So I just want to ask you on the allowance percentage. How does you put this percentage? What is your criteria to put a different percentage of allowance in this table?
Okay, thank you. I would like to answer. For the allowance, we have considered by the energy expended by the workers when they do the operation. Also the work attitude, like they are standing or sitting when they do the activity. Also their work movement on when they do the work. Their eye fatigue, like they need some focus or not when they working, such as the full focus or not don't need so for fully focus. Also the atmosphere condition on the production line and the temperature condition, also the lighting when they use the spring-wet production.
All right. So how do you set the standard? Is it came from the company itself, or you set by your team? You know, you agree with your team, and this is the best allowance that you're going to put here in the table.
We're considering that from the book for the allowance, like such as that have some criteria.
All right. So you, okay, I understood. So it means that you are also suggesting the allowance percentage as well to the companies, the new allowance percentage. Am I right?
Yes.
Right. Okay. All right. So I think that's from me. Okay. I see Associate Professor Dr. Adnan Hassan. Do you have question, Prof?
Yes. Okay. Thank you, Doctor, for giving me this opportunity. Okay. I just want to have a general question. Okay. What is the biggest challenge when you do this study?
Okay. For the biggest challenge that we've have for this study is when we gonna implement the new JSON layout, because we need to move the machine on the Spring-Batch production line. Also, on the when we implement the setup time, we need to set new activity. Also, because of the COVID-19, we have hard time when we go to the factory.
So collecting data is a challenge, is it?
No, implementing the data that we have, and also the collecting data also some challenge, of course, because of the COVID-19 pandemic.
Okay. So okay, you are now in the competition for Six Sigma, right? Is it correct?
Yes.
Okay. How you relate your methodology to Six Sigma methodology in doing your study?
Okay, because our study consists of lens manufacturing approach, such as using the value stream mapping. Of course, we use single minute exchange of dice, and also from the waste analysis, we created the new lane on the Spring-Batch production line, which is minimize the non-value added activity, also increasing the efficiency on Spring-Batch production line.
I see. So because I look at your paper, you did not mention anything on this DMAIC methodology, right? Is it correct?
Can you repeat the question, sir?
Okay, I look at your paper. Okay, you did not mention anything on DMAIC methodology, but this is a typical methods when we are solving or addressing Six Sigma projects, you know.
Oh yes, we're not using DMAIC for this DMAIC method for this Lean Six Sigma. We're just focusing on increasing the efficiency on the Spring-Batch production line productivity.
Okay, I understand that. So I think your study have reduced the setup time. Is it correct?
Yeah, yes, we're decreasing the setup time, also the production time and the lead time.
So this has been implemented or not, or you just on paper?
Yes, this have been implemented on the factory on the Spring-Batch production line.
Okay. All right. That's all for me. Thank you.
All right, thank you very much. Thank you very much for your answering the question and for your question as well, Prof. Right? Okay, so we're finished now. Thank you very much. So we are going to the next presenter. Thank you very much. Thank you very much. It was a good presentation as well.